Hi friends, welcome back to Acharya Gurukula. Today's topic is K nearest neighbors, a solved example. In this video, I am going to explain introduction to KNN, determination of K, statistical methods for K, and solved example. K nearest neighbor classifies are defined as classifying unlabeled examples by assigning them the class of most similar labeled examples by their characteristics. It is extremely powerful algorithm due to its simplicity. KNN is mostly used for classification tasks. It stores all available cases and classifies new cases based on similar features. KNN is a parameter that refers to the number of nearest neighbors to include the majority voting process. Algorithm begins with the training dataset made up of examples that are classified into several categories as labeled by a nominal variable. Assume that we have a test dataset containing unlabeled examples that otherwise have the same features as the training data. For each record in the dataset, KNN identifies K records in the training data that are the nearest in similarity, where K is the integer specified in advance. The unlabeled test instance is assigned the class of the majority of the K nearest neighbors. Step is how to choose the value of K for KNN algorithm. KNN algorithm is based on feature similarity. Choosing the right value of K is a process called parameter tuning and is important for better tuning. The value of K is critical in KNN as it determines the number of neighbors to consider when making predictions. Selecting the optimal value of K depends on the characteristics of input data. If the dataset has high significant outliers, a high K can help smooth out predictions and reduce the outliers data. However, choosing a very high value of K can lead underfitting. The choice of K will largely depends on the input data. Next step is statistical methods for determining K. So these are the two methods that are determining for K. One is cross-validation and the other one is elbow method. The cross-validation involves splitting the data into K subsets, training the model on some subsets and testing on it remaining the repeating for such subsets. The value of K that results in the highest average validation accuracy is the better choice. Second method is the elbow method. We plot the model error rate or accuracy for different values of K. As the value of K increases, the error usually decreases initially. Here you can see the graph below. However, after a certain point, the error rate starts to decrease more slowly. So this point where the curve forms an elbow, that point is considered as the best K. We solved an example for KNN algorithm. Here a plot is drawn between load versus displacement. On the right side, you can see the data set ranging from 1 mm to 50 mm as a displacement and the load value 1.5 kilonewtons to 173.46 kilonewtons. A graph is drawn between P versus delta and some of the data points are shown here. Not all the points are plotted here. To make you understand more clearly, the data points that are denoted with the green color are linear and the red color are non-linear. Now, the point which is shown in yellow color has the coordinates 17 and 139. 17 is the displacement and 139 is the load. Now, we need to determine the point comes either linear category or non-linear category using KNN algorithm. The first step is to determine the distance from the point xy to all the points. So here are the you have a column which denotes the distance. It determines the distance from xy to the point delta and p. So here, these are the distance values that are given, and the distance is calculated using Euclidean distance. So the Euclidean distance equation is x1 minus x whole square plus y1 minus y whole square under root. So we have other distance calculations also, like Manhattan distance and cosine distance. Here in this, I consider Euclidean distance only. The second step is find out the ranking. So whatever the distance that we calculated, the least distance we give the ranking one. So out of all the distance values, the least distance value is 5.04876 is the least distance. So hence I provide ranking one. So similarly, ranking two, the next immediate distance is 11.367. So the ranking value is 2. So like that, the ranking values are given for all the points. Third one, find out the nearest neighbor. So if k is equal to 1, that is this one, if k is equal to 1, it is classified as linear. Now, if k is equal to 2, then it is classified as linear or non-linear. If k is equal to 3, then it comes under non-linear. If k is equal to 5, then also it classifies as non-linear. So hence uh, the point x comma y that comes under non-linear category. So that means the point x comma y is classified as non-linear category using KNN algorithm. Thank you, Jai Hind.